Hello, my dear students. We are going to start with fractional distillation. So, next topic is fractional distillation. This process is used to separate when this method is used to separate a mixture of a mixture of two or more miscible liquids having a boiling point close to each other. Having their boiling points close to each other, right? Okay. Next, the fractionating column is used fractionating column is used it is a long tube provided with obstructions to the passage obstructions to the passage of the vapors moving upwards and most importantly the liquid moves in opposite direction, liquid moving downwards. Basically in this technique if we are having a mixture of two or more miscible liquids and their boiling point are very close to each other, I mean if the difference in the boiling point of the different components of the mixture is less than 30 kelvins, 25 kelvins, then we use fractionating column. Fractionating column, it is a long tube, okay, having the obstructions. Okay, these obstructions, they provide obstruction to the passage of vapors. Vapors move upwards, and because of the heat release in the form of latent heat of vaporization helps the other liquid, the second liquid, to get vaporized. Okay, like one liquid is getting vaporized, it will release the heat in the form of latent heat of vaporization. The latent heat of vaporization released will basically help to increase the temperature of the liquid just beneath the second liquid or the third liquid. The liquid moves downwards, okay, and their vapors come upwards. Okay, it is used to separate acetone. Acetone, the boiling point of acetone is 330 Kelvin, and methyl alcohol and methyl or methanol having a boiling point very close to each other, boiling point 338 Kelvin. Okay, there is a another fraction type of fractional distillation which is done under the reduced pressure, which is known as what, vacuum distillation. So that is a distillation under reduced pressure, also known as vacuum distillation under reduced pressure or vacuum distillation. There are certain liquids, they have tendency to get decomposed to get decomposed at a temperature below their boiling points, below their boiling points. Such liquids cannot be purified by ordinary distillation. Such liquids cannot be purified by ordinary distillation, right? Therefore, vacuum distillation is used for those liquids to separate them. Okay. So liquids which get decomposed below their boiling points, they need to separate from their mixture. So it becomes very hard to separate them because the moment we are going to separate them, we increase the temperature. The moment they release, they reaches to their boiling point below. Before that, they get decomposed. So that is why this method that is known as what vacuum distillation or distillation under reduced pressure is used. Okay. For example, glycerol boils with decomposition at 563 Kelvin. Okay. Next is steam distillation. Steam distillation. It is used for the separation of liquid, means separation purification of liquid, used for separation and purification of liquids which are volatile in steam. When they are not volatile in liquid, they are volatile in steam from non-volatile components of a mixture. Understood? Yeah. This process of steam distillation is used to purify the substances which are volatile in steam but are not miscible with water. Okay. So the components which are not miscible with water but are volatile in steam are separated by this method, are separated and purified by steam distillation, the process of steam distillation. Okay. Secondly, components having high vapor pressure at the boiling point at the boiling point of water, that is 100 degrees Celsius, means the water when it boils at 100 degrees Celsius at this boiling point, okay, the components of the mixture, they reaches to their maximum vapor pressure or very high vapor pressure. Okay. Then they contain non-volatile impurities, or they should contain non-volatile impurities. Impurity should be non-volatile. Okay. Example, mixture of ortho and para-nitrophenols. Ortho and para-nitrophenols are separated by this method. Okay. As you know, orthonitrophenol is having intramolecular hydrogen bonding, and para-nitrophenol is having intermolecular hydrogen bonding. Therefore, orthonitrophenol means the intramolecular hydrogen bonding is weak and this is strong comparatively. Okay, so orthonitrophenol, it comes into its vapor phase, it gets volatile in steam. Okay, so it can be separated, it can vaporize in steam of solvent, leaving behind para-nitrophenol. Okay, understood? Yeah. The next technique, which is very, very, very important, is chromatography. Chromatography. You know, chroma means color, graphy means study. Graphy simply means study. So this study, the science of chromatography, help us to differentiate the different components of colors on the basis of their extent of adsorption on a particular moving phase or a adsorbent. This method is used. This method is based on the difference in the rates of adsorption. Adsorption means surface absorption, as you know. This method is based on the difference in the rates of adsorption of different components of a given mixture on adsorbent. Okay. See what is adsorbent? There are two terms I will like to tell you. Adsorption is a surface phenomenon when surface particles they react or they interact with other particles. Okay, when the surface particles they react or they interact with the other particles and do not let them to cross them in between. Okay, for example, we are having a solid surface. This is a solid charcoal. I have crushed the solid charcoal and keep it in a glass beaker, and from the top I am releasing some gas, okay, some gas particles. So these gas particles, they will adsorb on the surface, okay, because surface particles, they are under the influence of unbalanced forces, and because of these unbalanced forces they are very reactive. The surface molecules are having unbalanced forces, and that's why they are highly reactive. Okay, so these surface particles, they the surface, this is activated charcoal, and this is suppose carbon monoxide gas, okay, or sulfur dioxide gas. The gas particles, they will only attach on the surface, they will not go in between, they will not go in the bulk, okay. That is why this adsorption is known as what? A surface phenomenon, okay. So the surface particles, they are highly energetic because of unbalanced forces. That is why they tend to react first. When they react, okay, if they are only reacting, the bulk particles are not reacting, then it is actually the adsorption. So chromatography is based on the difference in the rates of adsorption of different components of a given mixture on adsorbent. There are two terms. One is adsorbate, which is like solute, and the other one is adsorbent, which is like solvent. So adsorbate and adsorbent, they make adsorption. Okay. Now there are many forms of chromatography. First is column chromatography. Second is paper chromatography. Third is thin layer chromatography, gas chromatography. Okay. So these chromatography techniques, they are the most common: paper chromatography, column chromatography, thin layer chromatography, gas chromatography. Okay. Among which the most common is column chromatography. Most common, sorry. Okay. Applications. Applications of chromatography. The first is to separate ortho and para-nitroanilenes. To separate ortho and para-nitroanilenes. Secondly, to separate blue and red dyes. As I've already told you, that chromatography is used to separate the different components of color. Third, to separate and purify plant pigments and other natural products. Plant pigments and other natural products. Okay. Now, based on the principle involved in chromatography. They are further classified as adsorption, adsorption chromatography, and partition chromatography. Okay. Now, adsorption chromatography. Chromatography. What is adsorption chromatography? Adsorption chromatography, it is based on the fact that different compounds have different extent of adsorption, are adsorbed on a particular adsorbent to different degrees, to different extent. Okay. The most commonly used adsorbents are silica gel and alumina, Al2O3. Okay. There are two phases. One is the stationary phase, one is the mobile phase. When a mobile phase is allowed to move over a stationary phase, stationary phase is adsorbent. The components of the mixture move by varying distances over the stationary phase. That is adsorbent. Okay. So on the basis of differential adsorption, it is of two types. One is column chromatography, thin layer chromatography. Okay. Column chromatography and thin layer chromatography. Column chromatography It involves the separation of a mixture over a column of adsorbent. It involves separation of mixture over a column of adsorbent. Over a column of adsorbent, that is stationary phase, packed in a glass tube. Next, the column is fitted with a stopcock at its lower end. Is fitted with stopcock at its lower end. The mixture adsorbed on the adsorbent is placed on the top of the adsorbent. The mixture adsorbed on the adsorbent is placed on the top of adsorbent column, okay, in that glass tube. An appropriate eluent, which is the moving phase, or we can say the adsorbate is the moving phase, okay. An appropriate eluent, which is a liquid or a mixture, which is a liquid or a mixture of liquids, is allowed to flow down the column slowly, okay. Next, depending upon the degree to which the compounds are adsorbed, complete separation takes place. Depending upon the degree of adsorption, that is most adsorbed at the top, which is followed by moderately absorbed at the middle, and then the least adsorbed at the bottom. Okay, is it understood? So this is about the column chromatography, thin layer chromatography, and the other forms of chromatography we will discuss in the next turn. Till then, bye bye, take care, stay safe, stay healthy.